Hello, Math 140 students. This is Cindy Enrique, and we are going to continue lecturing on Chapter 6, and we will continue with Section 6.6, Solving Quadratic Equations by Factoring. So hopefully by now you feel a little bit comfortable with factoring, because now that's just going to be part of what we do. We factor and we solve. So we solve by factoring. So we know that a quadratic has a degree 2 polynomial. So that's that ax squared plus bx plus c. So this is the general form for a degree 2 polynomial, and we know we call that a quadratic, or you know that it's a degree 2. You also know it looks like a parabola. So the zero product principle, what that tells us is that if two numbers multiply together to give me 0, then one of the numbers gives me 0. For example, if I have 5x is equal to 0, then it must mean that x is equal to 0, okay? All right, so here we go. Solving a quadratic equation by factoring. Here are our steps. So for example number 1, it says to solve. So step number 1, it says write the equation in the form ax squared plus bx plus c is equal to 0. So the most important thing that you want to realize here is the first thing you want to do is set to 0. So here you want to make sure that it equals to 0. So that's going to be my first step. So in order for this to be equal to 0, I'm going to have to subtract the 12. So that means I'm going to have to subtract 12 from both sides. So I'm going to have this as 2x squared minus 5x minus 12 is equal to 0. So then from here, there are a couple of ways that you can factor. I know a lot of students really like the AC factoring method, and that's fine. So here, my A is equal to 2, my B is equal to negative 5, and my C value is equal to negative 12. So when I do the AC method, I have A times C up on top, and my B down at the bottom. And I'm going to rewrite this using my new B values. Okay, so then up on top, what I have A times C, so 2 times my negative 12 is going to give me a negative 24. My original B value here is negative 5. So I want two numbers to multiply to negative 24 but adds to negative 5. And if you want, you can kind of just put all your multiples of 24 over to one side. I know 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So here the combination that's going to add up to negative 5 would be my 3 and my 8. If I had a negative 8 and a positive 3, that gives me negative 5. So that is how I'm going to rewrite that middle term. So I'm going to rewrite this as my 2x squared. And since that middle term, I have that now as a negative 8x and a positive 3x. And don't forget that I have my minus 12 equal to 0. So I'm going to split it in half. The first two, what they have in common is a 2x. So I'm left with an x minus a 4. Then I have a positive 3. Then I have an x minus a 4 equal to 0. So I'm going to have x minus 4 and my 2x plus 3 as it factors. So I have x minus 4 is equal to 0. And so x is equal to positive 4. I'm going to have my 2x plus 3 is equal to 0. So 2x is equal to a negative 3. So x is equal to a negative 3 halves. So now I have my two answers. X is equal to 4 and x is equal to a negative 3 halves. And the way I was able to do that was to, set to 0, factor completely, and then I applied the ZPP, the zero product property, okay? All right, so now for the next example, I have my 9x squared is equal to 21x. Again, the first thing I want to do is set to 0. So I'm going to subtract 21x from both sides. So I'm going to have 9x squared minus 21x is equal to 0. So now, as a factor, I only have two terms. So I want to think about the greatest common factor. Here, my greatest common factor is going to be, I think it's 9. Let's see, 21 divided by 9. Does that work? It doesn't, actually. So maybe it's 3. I think it is going to be 3. So 3 is my GCF. So 3 times 3 is 9. Ooh, and they both have an x. So actually, my GCF is 3x. So 3x times 3x is a 9x squared. And then 21 divided by 3 gives me 7. So now I said each thing equal to 0. I'm applying the zero product principle. So 3x is equal to 0. So then x is equal to 0. I have my 3x minus 7 is equal to 0. So 3x is equal to 7. So x is equal to my 7/3. So now I have my two answers. X is equal to 0 and x is equal to 7 divided by 3. So notice that, the first step is always to set it equal to 0, factor, and then also apply the zero product principle. Okay, I hope that makes sense. For number 3, again, I'm still trying to solve for this, so I need to set this equal to 0. And I see I have a lot going on. So maybe you might be thinking, hey, I'm going to have to distribute here as well. So I'm going to have 9 times 4, which is my 36x squared, 9 times 2, which is a positive 18x, and I still have a negative 10x, is equal to 8x plus 25. So 36x squared. Now I'm going to combine these two together. So if I have 18 minus 10, that gives me a positive 8x. And I still have this equal to an 8x plus 25. So now I'm going to subtract this. So minus 8x from both sides. And I'm also going to subtract 25 from both sides as well. So there it cancels. So I'm left with a 36x squared. The 8x cancels on both sides. Minus 25 is equal to 0. So how am I supposed to factor a two-term polynomial? Well, here I can actually see that these are going to be perfect squares. So the perfect squares, 6 times 6 is 36. 5 times 5 is 25. So now I know how I'm going to be writing my conjugate pairs. So I know I have 6x minus 5. And the conjugate pair means it's going to be addition, opposite sign. So 6x plus 5 is equal to 0. Now, applying the zero product principle, I'm going to set each parentheses equal to 0. So I have 6x minus 5 is equal to 0. So then 6x is equal to a positive 5. And I divide by 6, so I have a positive 5/6. And on the opposite side, this parentheses, 6x plus 5 is equal to 0. So then 6x is equal to a negative 5. So x is equal to a negative 5/6. So now I have my answer, what x is going to equal to. All right. And that's it for example number 3. For example number 4, what's really nice about that it's already set to 0. So there's not a whole lot of work I need to do. That means I'm going to set each parentheses equal to 0. So 3 is equal to 0. W plus 2 is equal to 0. 2w plus 1 is equal to 0. And w minus 8 is equal to 0. So I just wanted to write everything down first. So now for the first one. Is it even possible for 3 to equal to 0? Never. So we just throw that one out. So then for the next one, I'm going to subtract 2 from both sides. So w is equal to a negative 2. So that is going to be one answer that's going to be legit. Here, I'm going to subtract 1 from both sides. And then if I divide by 2, I have a negative 1/2 that this is equal to. And here I'm going to add 8 to both sides. So W, oops. So then my W is going to equal to a positive 8 since I added 8 to both sides. So here I'm actually going to have 3 possible answers. This one was really nice because it was already equals to 0. So there's not much that I needed to do. For example number 5, this is really nice as well. This one's already set to 0. So again, that makes us happy because that makes us do less work. Now, this is a 4-term polynomial. If I have 4 terms, that's right, we do factor by grouping. So now I know that I'm going to split it in half and factor out the first 2 and then the last 2. So I'm going to have this as x squared as a GCF. So I'll have an x plus 1. On the opposite side, it looks like it has a 9 in common, so I'll have an x plus 1, all equal to 0. So x plus 1 is the common binomial factor, and I have an x squared minus 9, all equal to 0. But don't forget that this is also a difference of squares. This can go even further. 9, the perfect square root, is 3. So I have x and x. And since it's the difference of squares, I know I'm going to have opposite signs. So I have plus and minus. And don't forget that I have that x plus 1, and all of this is equal to 0. So now applying the ZPP, I'm going to set each parentheses equal to 0. So x plus 1 is equal to 0. Now if I subtract 1, x is equal to a negative 1. X plus 3 is equal to 0. So I'm going to subtract 3 from both sides. So x is equal to a negative 3. I also have x minus 3 is equal to 0. So then I add 3 to both sides. So then x is equal to a positive 3. So here I have my 3 possible answers. Okay? Alright, so down below we're going to have some practice problems. And it looks like we have 5 practice problems. So I would highly encourage you guys to press pause and you guys work on these practice problems. So I'm going to press pause. Okay, so hopefully you worked out the problems as you press paused, and here are the answers. So for number 1, it was already set equal to 0, so the answers are 6 and negative 1. For number 2 as well, it was already equal to 0, so my answers are 0 and positive 2/3. For number 3, I had a factor. Whether you do the AC method or you do the guess and check, you should come out with 1/2 and negative 5. For number 4, I had a GCF, so the greatest common factor was 4x. I pulled that out, and then I factored the inside. Again, you can do that either AC method or by guess and check. So you get 3 different answers, 0, 1/3, and negative 2. And for number 5, which is different than the rest of them, as you can see, is that for number 5, it's not equal to 0. So I'm going to have to do more work. So what I ended up doing here is that I ended up foiling. So when I foiled, I combined like terms, and then what I did is I added the positive 18 to both sides. So that way I can get the 0, and then I factored, and so I got my answer to be positive 5 and negative 2. And if you guys have any questions, please feel free to contact me or go to the Math Success Center for more help. So the next one, now we're going to be dealing with word problems and our factoring. So example number 1, the product of 2 consecutive odd natural numbers is 195. Find the numbers. So here, natural numbers. Hopefully you remember that natural numbers is a set of numbers how you naturally count. So I naturally count 1, 2, 3, and so on, right? So you start at 1, and so they're positive whole numbers. No fractions, no decimals, not a 0, but positive whole numbers, okay? That is what a natural number is. And so 2 consecutive odd integers. So here, consecutive odd. So what that is telling us is, hey, if we're on the number line, let's say we're at 3. and I want to get to 5. The way that I would do that is x plus 2. So I would go ahead and add 2 to that. So I know that I have my first number plus my second number. Oops, it's not plus. I should have read this a little bit more carefully. It is the product. So what does product mean? Product tells you to multiply. So you are multiplying the product. You're multiplying two numbers together, and that tells you that it's equal to the 195. So if I'm looking at two consecutive odd integers, I know the first one, I don't know what it is, it's x. But I know to count to the next odd integer, let's say we start at 3 to get to 5, what you do is you add 2. So x plus 2. So you really have x times x plus 2 is equal to 195. So now I want to go ahead and solve this problem. So I'm going to factor. Remember, I have to set this equal to 0. So x squared plus 2x is equal to 195. So then x squared plus 2x. To get this equal to 0, I'm going to subtract 195 from both sides. And now I'm going to factor. Whether you do the AC method or the guess and check, hopefully you can get this. So 195, I know that's 15 times 13. And if I want a positive 2, that would be a positive 15 and a negative 13. So x plus 15 is equal to 0. So x is equal to a negative 15. X minus 13 is equal to 0. So x is equal to a positive 13. So remember here, it specifically said a natural number. So if it's a natural number, negative 15 is not natural. It is not positive, therefore not natural. So 13 is a natural number. So x is equal to 13. So what is x plus 2 equal to? Well, 13 plus 2 is 15. So your two numbers are 13 and 15. Now I'm just going to rewrite that. 13 and 15. Okay? So those are the two natural consecutive odd integers. Okay? So, for example number 2, we have the Pythagorean theorem. The Pythagorean theorem says that whenever you have a right triangle, the leg squared plus the leg squared equals the hypotenuse squared. So it only has to do with a right triangle. And the right triangle has a 90 degrees, and it kind of looks like this box. So that right triangle, that 90 degrees, once we see that box, we know that it's 90 degrees. We also know that the hypotenuse is always going to be directly across from that box. So this is one of my legs, and that's my other leg. So now that I have the setup, I can plug in my values. So I have leg squared. So the first leg that I can write, let's say, is 5. So I have 5 squared plus my other leg, which is 12 squared, is equal to my hypotenuse squared. I don't know what that is, so let's call it x. So 5 squared is 25. And if I have 12 squared, well, that's 12 times 12. So that's 144 is equal to my x squared. So 144 plus 25 gives you 169 is equal to my x squared. So in order to undo the square, I square root both sides. So I have plus and minus the square root of 169 is equal to x. And the square root of 169 is 13. So this is saying that x is equal to a positive 13 and x is equal to a negative 13. But you have to be careful. If I'm finding length is never negative. That's something you always want to keep in mind. length is never negative. So the fact that I have a negative number, that's not going to work. So the only possible answer here is x is equal to 13. So the hypotenuse is actually 13 feet. So my missing side is 13 feet. Okay. So now for example number 3. It says a couple is remodeling their house. The addition will be in the shape of a rectangle. So that's good, a rectangle. So I know that a rectangle more or less looks like that. And the room's floor will have an area of 270 feet. So now I'm talking about area. So if I have area, that's everything on the inside. So I have 270, and it's my feet squared. So that's everything on the inside is area. The width of the room is to be 3 feet less than the length. So that then kind of gives you your point of reference. So whatever comes behind it is the I don't know. So the I don't know is always going to be x. So here my x is equal to my length. So if the width is supposed to be 3 feet less than that, then it's going to be x minus 3. So x minus 3 is equal to my width. So if it specifically says to find the dimensions of the floor, the dimensions just means the length and the width. Okay. So now that I have my picture set up and I have some formulas, now I can go ahead and start plugging it in. I know that the general equation for area of a rectangle is area is equal to length times width. So I'm just going to start plugging some stuff in. Well, I know that the area was 270. I know that the length, I call it x, and the width, I called it x minus 3. So I have 270 is equal to x squared minus 3x. I distributed that x inside the parentheses. So then from here, I'm going to go ahead and minus that negative 270 from both sides. So I have x squared minus 3x minus 270. So now I want to think about all of the numbers that multiply together to give me 270. And I can list them one by one, or I can start just listing them and seeing which one is going to get me closer and closer to that 3. I also have 9 times 30. Let's see. Okay. So I finished writing down all of my multiples of 270. I should have gone in order, but that's okay that I didn't. So those are all of my multiples. So if I multiply those two numbers together, it gives me 270. So I want the middle term to be 3. So it looks like 15 and 8 will give me a 3. So I know how I'm going to rewrite this. So I know x times x is x squared. I know that 15 times 18 is 270. And if I have a negative 18 and a positive 15, that gives me a negative 3. So now I'm going to set each parenthesis equal to 0. So let's see. So I'm going to have x plus 15 is equal to 0. So x is equal to a negative 15. X minus 18 is equal to 0. So I have that x is equal to a positive 18. So remember what I said before, measurement, dimensions, length, width, or even time cannot be negative. So because I'm talking about measurement, I cannot have negative 15 feet or negative 15 inches, right? So I'm going to have x is equal to 18. So what did x represent? Oh, it represented my length. So I have that my length is going to be 18 feet. So then my width is minus 3. So 18 minus 3 gives me 15 feet. So I have my length of 18 feet and I have my width of 15 feet. Okay. So these are the types of word problems that you're going to be encountering on your homework. So for number 4, it says use the formula where h is the final height in feet, t is the time of travel in seconds, v naught is the initial velocity in feet per second, h naught is the initial height in feet of the object traveling upward. So really, just know that we're using this formula, okay? All right, so a ball is thrown upward 4 feet per second from a building 29 feet high. When will the ball be at 9 feet above the ground? Well, thank goodness it gave me a formula. So I know for sure that I'm going to be using that h is equal to a negative 16 t squared plus my v naught times t plus my h naught. Now I just need to figure out what variable gets plugged in where. So let's see. Well, it says that my building is 29 feet high. So this is my initial height. So the initial height says it's h naught. So I have that my h naught is equal to 29. Perfect. Now it says a ball is thrown upward at 4 feet per second. So that 4 feet per second, well, I know that I have my feet per second. So if I'm matching my units, that's my initial velocity. So that's going to be my v naught. So v naught is equal to 4 feet per second. Feet per second. So I'm definitely making use of that feet per second, feet per second. Okay, so the last thing they have is when will the ball be 9 feet above the ground? So when is the final height which is just h going to be at 9? So when they're referring to here is time. So when is time? That's the I don't know. That's what you're trying to figure out. So now I'm going to plug in my values. So for the h here, I know that's 9 is equal to a negative 16 t squared. That v naught that we talked about before, that my velocity is going to be 4. And the t, I do not know. And my initial height, that h naught, we said that that was going to be 29. So what I'm going to do first is I'm going to subtract 9 from both sides so I can get a 0. So 0 is equal to a negative 16 t squared plus 4t plus 20. And then from here, I can see that I have a GCF. The GCF here, that they can all be divided by a 4. And better yet, the leading coefficient is negative. So my GCF is going to be a negative 4. So I'm going to have a 4t squared minus 1t minus 5. So now I need to factor that 4t squared minus t minus 5. So you can do this over to the side if you need to. So I know that if I want the middle term to be a 1, the best way is 4 and 5. So I'm going to have a 4t for the first one. And for the 5, I'm going to have 5 here and 1 here. And since the 1 is negative, I'm going to have a negative 5 and a positive 1. Perfect. So now I have negative 4 is equal to 0. 4t minus 5 is equal to 0. So then my 4t is equal to a positive 5. So t is equal to 5/4. T plus 1 is equal to 0. So t is equal to a negative 1. And remember, time cannot be negative. So negative 4 is equal to 0 doesn't work. Negative time, this is not Back to the Future. I cannot go back in time, so that's not right. So the only answer is 5/4. Or if you really want to get technical, 5/4 is 1.25 seconds. So 1.25 seconds. So after 1.25 seconds, the ball will be at 9 feet. Okay? All right. So that concludes example number 4. And we have some practice problems. We have practice problems 1 and 2. So we only have 2 practice problems for you guys, okay? So go ahead and press pause and work these out, and I'll show you the answers. So press pause. Okay, so that took me a few minutes. So hopefully you guys press pause as well and work these out. So for number 1, the product of 2 consecutive integers is 35. Notice how for this one, it doesn't say natural or positive or negative. It just says integers. So integers are positive and negative. So remember, my integers is a set like -3, -2, -1, 0, 1, 2. So it's my positive and negative numbers that are whole numbers. So I got 5 and -7. So 5 and 7 is the first pair, and -7 and -5 is my second pair. For the second example, I had the length of a basketball court, and so I drew it out to help myself out, and then I factored, and so I got my width to be 50 feet, and I got my length to be 94 feet. And again, these were practice problems, so I really hope that you guys took the initiative to try to work these out. The only reason I gave you the answer was for you to check it to make sure that you guys were on the right track. But please, please, please make sure that you guys are actually trying to do these practice problems on your own. Okay, and I believe that is the end of section 6.6, and it is. All right, so stay tuned for the next section.